All right, complex fractions are just fractional expressions with separate fractions in the numerator, denominator, or both. So some examples, we've maybe seen something like this before. Maybe it's like, 3/4 divided by 1/2, right? We have a fraction divided by a fraction. But remember, I can just write this as 3/4 divided by 1/2. And this is the same thing as 3/4 times 2/1. And if I just, reduce the 2 and the 4 here, this is just 3/2. All right, so you can have a fraction divided by a fraction, but just remember, you can rewrite that however you want. You can use the division symbol to help you out there. So we have two methods of simplifying these complex fractions. All right, the first method is by combining the fractions in the numerator into a single fraction. So the only way I could do this in my numerator is if both of these fractions had an x in the denominator, right? That's the only way I could go about doing this, because I know that I can only add or subtract fractions if they have the same denominator. So right now, we've got 2/x minus, this is like 3/1, right? But I have to have an x down here somehow. So the only way to get that to happen is to multiply by x/x, all right? So this is what I want to do, because if I look at what I have now, this is going to come out to be 2/x minus 3x/x, right? And I know that now that I have the same denominator, I can combine these terms. So we've got 2 minus 3x/x, and that is my numerator, all right? So we figured out the numerator. Second step is to combine the fractions in the denominator into a single fraction. So I'm going to take this whole thing down here, and I look and I see I've got an x minus 1 in the denominator. And that means that I also want to have an x minus 1 in this denominator too. But I can't just throw in an x minus 1 there. I have to make sure I'm not changing the value of this expression, right? So I've got to multiply by a fraction equal to 1. So what I'm going to have to do is I'm going to have to take this 1 and multiply it by x minus 1 over x minus 1. And then I've got the rest of this expression. Then I've got the minus 1 over x minus 1. Okay, so again, the reason why we did this is because now I'm going to have the same denominator, and I can go about combining these two fractions now. So now I've got x minus 1 over x minus 1 minus 1 over x minus 1. And so if I just combine these like terms into one fraction over x minus 1, I see that we've got an x, right? And then negative 1 minus 1 is negative 2. All right, so there we go. We've combined the numerator into a single fraction, and we've combined the denominator into a single fraction. So what I have to do now is rewrite this using the division symbol, and then we're going to divide and simplify. So I'm going to write this as 2 minus 3x over x divided by x minus 2 over x minus 1. I know that I can rewrite this as 2 minus 3x over x times x minus 1 over x minus 2. All right, and now if I look, there's nothing that I can really cancel, nothing like that at all. So this is actually just going to be our final answer. We've got 2 minus 3x times x minus 1 all over x times x minus 2. All right, and that is going to be our final answer. For this one, you do not have to find the domain. All right, so we just simplified that, and we are all good. That's method 1. Method number 2 is to multiply the entire numerator and the entire denominator by the LCD of all the fractions. So when I look at the numerator, I see x. When I look at the denominator, I see that the denominator is x minus 1. So that means in this problem, the LCD is x times x minus 1. Okay, I have to include the x, and I have to include the x minus 1 in the LCD. So what this means is I'm going to multiply every single term by x minus 1, right? So I'm going to multiply the numerator by x minus 1 and the denominator x minus 1, all right? And when I do this, I am going to have to distribute this to both terms, and I'll have to distribute all of this to both terms, right? So a lot of distributing here, but we should notice some fractions start to eliminate and cancel out here, all right? So when I do this, I'm going to take the 2 over x, right? I took the 2 over x. I'm going to multiply that by x minus 1, all right? And then we see we have a minus 3. So I'm going to take the minus 3 and multiply that by x minus 1, all right? I'm now going to go to my denominator, and we see we have a 1. So I'm going to write down the 1. I'm going to multiply that by x minus 1. And then we have minus this fraction here, so I'm going to copy paste that. And I'm going to multiply that by x minus 1. All right, so now we should see some things start to cancel here. I see in this first bit that we've got an x in the numerator and denominator. And then I see in this bit in the denominator that we have an x minus 1 and an x minus 1 top and bottom of those fractions. So those will cancel as well. All right, so if I start simplifying, I'm looking in the numerator, and it seems that we have 2 times x minus 1 minus 3x times x minus 1. Now, I don't want to distribute this yet because I see that I can maybe do some grouping strategies here. And then in the denominator, we've got x times x minus 1 minus 1 times x is just x, all right? So I'm not quite done yet. Notice that when I look at this numerator, right, I have 2 pieces, right? This first piece and this second piece. And I'm thinking to myself, well, wait a minute, what is common to both of them? I get to maybe take out a GCF, and I notice that common to both of them is an x minus 1, all right? So if x minus 1 is common to both of them, that means I'm trying to figure out what do I have left. And I have a 2 remaining from this first part, so there's my 2, and then I have a minus 3x remaining from my second part, so there's a minus 3x, right? This is just basically the last stage of grouping, all right? And then over on the bottom, I see the same idea, right? I'm looking at these 2 pieces, and I'm saying, hey, what do they both have in common? Maybe I could take out a GCF. So here, I notice they both have an x in common. So that means from this first part, I have an x minus 1 remaining. So here's my x minus 1. And then from the second part, if I took out an x, I've got a minus 1 remaining. All right? So at this point here, I can simplify the denominator, right? The numerator will stay the same, x minus 1, 2 minus 3x, all over x minus 2, all right? And this is going to be your final answer, and hopefully you notice that that is the same answer as we get above, all right? So it is up to you how you would like to simplify this, all right? Either method, it depends on what you're more comfortable with, but both those methods will give you the correct answer.